Hi everyone. In today's video I will be going over numbers 2 and 4. I've already made a video over 1 and 3. These are the tangent / cotangent graphs, so feel free to check that out. Today we're going to cover the secant / cosecant graphs. Reminder, the general form of the equation that we're using for this is y equals plus or minus, in case you have a fraction, a, and then your trig functions. So for this video, it's either going to be secant or cosecant of b. B goes outside the parentheses strictly. X plus or minus the phase shift plus or minus the vertical shift. Hopefully you already have that written on your paper. If not, go ahead and write it down. Alright, the process here is going to be very similar to the process I used for 1 and 3. There's going to be a couple changes just because of the different functions we're using. Otherwise, it should feel very similar. So, first thing you want to do in general when you look at any of these problems is identify which pair of functions we're looking at here. Hopefully you immediately pinpoint this as the secant / cosecant type of graph. Now these graphs, you are going to want to label some of the stuff that we would normally, if we were given an equation, and these are things that we would put on our graph that don't show up in the finished product. So, I mean they can, but like a computer generated graph will leave out some of these extra details that we like to add to make graphing easier. The first thing, I did this on 1 and 3, is the midline. You always want to find that midline. Remember, the midline is the middle of your graph. So for this in particular, it's going to be the point that's halfway between your max and your min. So our maxes go through 3, and then our mins go through 1. So you can do this a couple different ways. You can do trial and error, pick a number, make sure it works. Sorry, -1, not +1. So -1 up to 3, so that's a distance of 1, 2, 3, 4. So halfway would be a distance of 2, so I'm going to go down 2. Our midline goes through 1. Some of you are pretty good about eyeballing this, that's fine. Just make sure, if you eyeball it and you think you've got the right one, just make sure it's the same distance from the maxes to the mins. That's how you know you have the right one. So that's the midline. This goes through 1, so that means we have a vertical shift of 1 plus 1. Okay. Now on here, these can be hard to find starting points and stuff, so you want to fill in the points as if you were actually graphing this by hand, where the points would go. So these are our maxes. These, what we can see of them, are the mins. Remember, when you graph secant, cosecant, you're essentially graphing the sine or cosine curve, so you're graphing those points. So we have our maxes and our mins, and then there are midline points that they stop at as they switch between maxes and mins, they stop at the midline too. So these are actually kind of easy to identify. Find a max and a min that are next to each other. Well, consecutive, I should say. And so it's the interval in between, in the middle. That's where the midline is. So if this is where the max is, it goes through this value here. And my min goes through 0. Halfway in between is this interval. So that's going to be a midline point. So these are on the interval. So now I know the other midline point over here will be right there. And I'll go to the right. Min, so this is a midline. Max, midline, min. The last thing I'm going to do here is I'm actually going to draw in that curve. We typically don't draw this when we're graphing secant and cosecant. That actually is an option if you would like to do it. I personally avoid it, but that is just me. So there's our sine cosine curve. This is going to make finding starting points so much easier. Okay, so we're going to set up an equation. Y equals, haven't made it very far. You really need a starting point here. So, if you can, we start at the origin. Now, if we have the origin, our graph is at a minimum, so we can use this. Our origin is on the midline. It's right here. Now, we don't actually have a point here. Our point is down here at the minimum. Remember, cosine starting points are maxes and mins. So, since this is a min, that's a cosine starting point. But remember, cosine, natural cosine, starts up here at a maximum. Since we're starting at a minimum, that means we have negative cosine. Since we have negative cosine, we're going to have negative secant. So our function here is negative secant. Leave room for the a. B, x. Again, we start at the origin if we can, because then we don't have to worry about a phase shift. So no phase shift. Vertical shift is +1. A, you go to your midline, and then I like to work with maxes. So go up to meet the max, and then however many units that is. I go up 2. So A here is 2. All that's left is to find our B. So for this graph, the strategy to find B is to find the period, of course. So the best way to identify a period is to move from maximum to maximum. So I'm going to drop that there and I go until I hit another maximum. So it's max to max. That's going to be the length of a period. And then when I get the period value, I'll put it there. Okay, so let's figure out what these numbers are. That's negative pi. And then this is positive pi. Now remember, you can just do a simple subtraction here. You have to do right minus left if you're going to do this. If you go the opposite direction, it's not going to work. Pi minus negative pi plus. That's 2 pi. It's 1 pi plus 1 pi, 2 pi. So our period here is 2 pi. And then lastly, this is not B, this is the period. We use it to find B. So the period formula, period equals, now careful, tangent cotangent has a different formula from secant cosecant, which is also sine and cosine. This is period equals 2 pi over B. So tangent and cotangent, it's pi over B. Secant cosecant, again, which is also sine and cosine, it's 2 pi over B. So make sure you're aware of that change. Okay, we found the period, it's 2 pi. And then if you make this into a fraction, if you compare, the numerators are the same, so then the denominators have to be the same. So that means B equals 1 here. Just for kicks, I'll do the cross multiplying on number 4 because I'll have to. So I'll actually pause and not do the cross multiplying. If you cross multiply, you'll have B over here and then just 2 pi. You would divide off the 2 pi on both sides. They'd cancel out completely. B would just be 1. Okay, B is 1. All right, that's my first equation. My second equation, since I'm running out of space, I am going to write that down here. Y equals, we did secant the first time, so we're going to do cosecant down here. I'm not going to fill in A until I've established whether or not I have a reflection. I feel like that's just a responsible thing to do. B, we know, is 1. Now, because I've already used my no phase shift option, I have to have a phase shift, so I'm going to leave room for that. And then plus 1 for my vertical shift. So let's identify a cosecant starting point. So I said earlier, cosine, the natural cosine starts at maxes, so this would be a natural, not reflected cosine. And then reflected cosine is on the mins. So the only points left on the graph are your midline points, which is where a sine would start. Sine, remember, it always starts at the origin or on the midline. So Any of these four midline points would be options for a cosecant / sine starting point. So we could go to the left or the right here. Let's see. I'm going to go to the right, and I'll explain why in just a moment, why I chose that one specifically. Again, you have other options. So this is going to be my next starting point. So this is sine. And then I specifically chose this one because this is natural sine. I can tell because after the point, the graph goes up. That's what it's supposed to do. So this is positive sine, not a reflected sine, so we have a positive cosecant. Reflected sine would be like this one if I went left instead of right, because this would be my starting point, and then I go down immediately after. And that's not what sine is supposed to do. So that means we have a reflection here. So that way I can avoid a reflection, basically. So if I started here, I would have to include a reflection. Now that I know that this is a natural sine, therefore natural cosecant, no reflection, this is a positive 2. And now I just have to write in my phase shift. So to do my phase shift, I have to know how far over I went to the right. Well, if this is 0 and this is pi, halfway between those two is pi over 2. So this value here is pi over 2. I went right pi over 2. And then this is positive on the graph, so I put it in here. I'm going to put a minus in front of it. Change the sign. This is right pi over 2. And there's my two equations. Okay. Let's do that again. Number 4. Process. Identify the midline and draw in the curve. Let's see. The maxes are through 3 and the mins are through -3. When they're even, when they're the same number, just different signs, that's a dead giveaway that we are on the x-axis like we're supposed to be. Because halfway between +3 and -3 is 0. Here's our midline. Since we're on the x-axis like it's supposed to be, we have no vertical shift. So, no vertical shift to speak of here. Next, I'm going to mark the points on the graph that I can see. My maxes. Oh, I did that in pen earlier. Trying to be consistent. My mins. Now be very careful here. It would be very tempting to just try and pick an interval and place this, but hopefully on this side of the graph it's kind of obvious that there's something a little odd going on here. So, pick a pair, a max and min, that are consecutive. I'm going to come down to the x-axis and drop a tick mark where they are at. Hopefully you can see that they are not quite landing where they're supposed to be. When I say supposed to be, I'm going to clarify that in a moment. So, the midline point is halfway between these two. So that's going to be right here. So you should notice that these are landing in between the intervals. This is a tweener graph. So I'm keeping that in mind as I move from value to value. So my next in-between tweener is right here. Min, tweener, max. And then if I want to fill in this one over here, I can as well. And then there's my curve. There we go. Okay, so let's start our equation. Kind of hard to really fill in a lot of information because we haven't even figured out which function we have. So let's do that. To figure out which function we're looking at, we need a starting point. A good go-to starting point is the origin. However, we can't start here on this graph because if we do, the graph cuts through right here. It doesn't cut through the origin and it doesn't cut quite through the maximum yet. So this is not an option. This is not sine or cosine here. It's neither. So we have to have a phase shift, unfortunately. So we can go either left to this point or right to this point to start. Let's go left and to this point. So I'm going to shift my starting point here. And the reason I chose this one is because this is at a maximum. And hopefully you recognize that the maximum is the natural cosine starting point. So that's cosine, no reflection, because it's starting at the maximum like it's supposed to. So that means we have a natural secant. So that's what my first equation will be. Natural secant. We know that this is a positive here. Just establish that. A, B. Let's go ahead and fill in our phase shift because we did shift over to get to here. Let's kind of map this out a little bit. This is negative pi. And actually, I'm going to use, I get a little crowded on this problem, I remember that. So I'm going to use the bottom here to map out my values. This is negative pi. This is 0, so this is negative pi over 2. It's halfway in between 0 and negative pi. Now I need the value that's halfway between 0 and negative pi over 2. That is going to be negative pi over 4. So we went left pi over 4. So put in pi over 4. It's negative on the graph, so it's going to be positive when I put it in there. Change the sign. No vertical shift, so I'm not going to add a number to the end here. So now I just need to go back and find A and B. A is just your amplitude. So go to your midline and count up to your maximum. 1, 2, 3. A is 3. B, the period, this one's going to be kind of fun to find. Not really. Okay. So you do a maximum to a maximum. Max to max. So I need this value here. I've already found it. It's negative pi over 4. And I need this value there. Okay. We're going in between here. So if you haven't already noticed, this in between value, I can use the pi over 4 denominator. I can use the 4 denominator to figure out what all these values are. So this in between here is pi over 4. This is pi over 2, which should make sense. It's already mirroring the left side that I started to fill out. This is 3 pi over 4. This is 4 pi over 4, which is just pi, as it should be. That's what it says up here. So now I'm not going to write all of these because it's getting cramped. So I'm just going to talk. So this was 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That's the value that I need. So it's 4, 5, 6, 7 pi over 4. That's my right value. So I need to find the distance from negative pi over 4 to 7 pi over 4. Again, this can be done in a simple subtraction problem. Just make sure you do right minus left. 7 pi over 4 minus negative pi over 4 becomes a plus plus. This is a 1 pi. So it basically is 7 plus 1. So it's 8 pi over 4, which is 2 pi. So all that work just to get that the period is 2 pi. I'm not going to do the math again because discussed up here, period equals 2 pi over b. We're using the same formula here. The period up here was 2 pi. So then when I set it up, b is 1. So if my period's the same, my b will also be 1 here. And then actually, since I didn't show the cross multiplying for anyone who wants to see it, I'll go ahead and do it. I, for some reason, thought this one worked out differently, but it doesn't. So the setup's going to be exactly the same as number 2. And then if you're curious about the cross multiplying, 2 pi b, that's just 2 pi times 1. And then you solve for b, so you divide off the 2 pi on both sides. Cancel, cancel. B is just 1. So b is 1. Okay, there's my first equation. Second equation comes much quicker because I've done most of the work. My first equation was secant, so it has to be cosecant for the second one. So I'm going to look for a sine starting point. Reminder, cosine, secant, starts on maxes and mins. So my midline points are going to be my options for my cosecant sine starting points. So I can pick any of these four. If we want to avoid a reflection, we could choose either this one here or this one over here, because after the point it goes up. The other two go down, so you would have a reflected sign. Let's just go left a little bit more and choose this as our starting point. So this is a sine starting point, and as I've already said, it's natural because it goes up like it's supposed to. And then that means we just have a natural cosecant, no reflection. So my A is also positive 3. My B is still 1. We still do not have a vertical shift, and then we clearly do have a phase shift because we moved left even further to get to there. Okay, all that's left to figure out is what my phase shift distance is. How far left did I go? Now I already did some of this work over here because these mirror each other. So this value in between pi over 2 and pi was 3 pi over 4. I'm going to write it up here. So this is negative 3 pi over 4. That was my phase shift. Negative here, positive here. Switch the sign. So this is a plus 3 pi over 4 when I put it in the parentheses. And I'm done. That's my graph. Those are my equations. That is all for this video. If you have any additional questions, feel free to ask me via email or in person. Otherwise, I hope you have a wonderful day. Bye!